not an ultra-crepidarian. You know what that means? That means that someone's talking above their shoes. The story there is that an artist did a painting and he hung it up in public place, and then people came by and commented. And one time a shoemaker came by and says, oh, the guy's got the shoes all wrong. So the artist went out and looked at it and said, you know, he's right. So he redid the shoes and he put them back out there, and the shoemaker came by and said, oh, shoes are right now, but now the hair is wrong. Well, the thing is, he was a shoemaker. He knew what he was talking about on the shoes, but he didn't know what he was talking about on the hair. And so he was an ultra-crepidarian. So sometimes you run across those people and they'll tell you how to do something and they know nothing about it. Well, I'm an electrical engineer. I have spent 42 years in electrical design, and at one time in 1986 my team built the world's fastest computer for the Air Force. Wow. But let me tell you something. Computers are dumb. What you have here in the robotics C programming language is a compiler that takes your instructions and then translates that into machine instructions, because you don't want to be bothered with machine instructions. They're very simple. In fact, they are things like this. Now that's for a 5-bit machine, and most of our machines today are 32-bit or 64-bit. The things you're dealing with, I believe, are 16 bits. But it's still very simple instructions. And this instruction may say, take this number from this address and put it in this register. And then count, the next instruction may be 10111. It says take that register and decrement it, meaning reduce it by 1. And then every time it comes across this instruction, it reduces it by 1. So when you guys are pushing these little joysticks, you're telling it to call a machine routine that says run that machine, run that motor. The thing is, that motor can be updated as long as you're holding that thousands of times a second. It says run that machine, run that motor. If you keep holding that too long, you can burn the motor out or strip gears, because that motor's trying to turn. That's why you want to think about what you're doing to your robot so that you don't destroy it. And that's why in your kit there are things like a limit switch. And when this limit switch is pushed, it sends a signal out. And if you write your code properly, it says, turn that motor unless you've hit that limit switch. When you hit that limit switch, even if I tell you to turn the motor, don't. There's another thing in there, an optical encoder, which goes onto your shaft, and it will tell you where you're at. And you can set limits to that, saying, I only want to operate, turn that motor if I have not gone beyond 0 or beyond, something like 120 degrees. So that you can protect your robot when you're doing this. So as you get your robot working so that it does what you want it to do, think about what you can put into the code to protect it, and then what kind of sensors you can add to help protect it. Another thing you need to look at is the way you do gearing. Like the one team I was watching, they have an arm that raises up. The thing is, that arm, there's a motor with a gear on it, and it turns a bigger gear, so that it has a mechanical advantage to lift that arm. But the problem is, when they stop lifting that arm, the weight of this arm pushes it down, because now the reverse is true. This mechanical arm has a little bit of force to push this down, and that motor just turns back down. In some cases, they don't want that that arm to go down. They'd like to keep it up there and go down the line and push another thing over the block, over the wall. So rather than doing this kind of thing, you might want to look at linear activation. Because a linear bar with teeth, may not have the mechanical advantage to force it down, or in worm gear type things, you can actually lock it. So think about the way you're building your robot so that it does the things you want it to do, but also think about how you could limit that robot so that in the code, so that you don't break your robot. Okay? The other thing I've seen is these gearing things. You need to make sure that the support for those gears is very strong, both this way and this way. Because if they become misaligned such that you're over here, you have very little surface in contact, and then you can strip the gears. You want to make sure those gears are held in perfect alignment. So if you have to, take your robot apart and rebuild this structure so that it's stronger in there and supports that and keeps it in alignment. Because again, you'll strip the gears, and it may be fine here playing around, you can get another gear. But when you're in a competition, you don't have the chance to rebuild your robot. You go through one competition, and if you win, or even if you don't win the first few rounds, you're put into another competition. And if you don't have your robot ready to go, you lose. So you really need to be thinking about how you can do that. Later on, we'll talk more about some of the coding and stuff that does this, the subroutines and stuff. But basically, remember that computer's dumb. You have to tell it everything to do, and when you tell it to do something, it will do it, even if it breaks your robot. So you need to start thinking about limiting your robot's movement and how to stop it from hurting itself. Because you wouldn't like to